Hi, my name is Ed Blumdahl, and I'm going to give another video talk today. I have three other video talks that I've done. Uh, One is about Mr. Einstein's special theory of relativity. It's called Breaking the Light Barrier, Adding Velocities Beyond the Speed of Light. I have another that is about the universe and expanding, or I should say the expanding, not accelerating universe. In other words, the universe is not accelerating, it's just expanding, and that's the discovery from Mr. Edwin Hubble. The third one was the true story of the photon, and that basically demonstrates, lays out, talks about that the photon is not massless, that it in fact has to have mass, otherwise even Isaac Newton's third law of motion of action and reaction, or equal and opposite, would fail. So there's no other way around it. A mass, if that's to stay in, as accepted science, then the mass has to have a photon. There's no way around it. Now, today I'm going to discuss another topic. It's simple. It starts off simple, and it's nothing that you already don't know, but I just need to sort of explain a little bit about it, what it is, how it works, how it doesn't work, what you can do with it, what you can't do with it. And then we move on from there, and if you stay with me, like I said, there is a punchline to this, which maybe you wouldn't have anticipated. And the talk today is light in transition and Einstein's cross, or I call it LIT, light in transition, LIT. And people know Einstein's cross. If not, you can just look it up. It's all over the place. At least it's called Einstein cross. So let me go through a little background. As I said, this needs to be done, and then we can go on to something more interesting. Well, I mean, the idea is fairly simple for light in transition. I just did a basic definition here. It's light only. In other words, there are no objects other than photons, right? Light only between a source and the target. And, that's, we've known this since we were babies, right? That what this light is, maybe we didn't have a name for it, but that's basically what's going on. In other words, if you have a source, which can be absolutely anything, a flashlight, the sun, a star, anything, right? Light moves away from that under certain conditions, travels, can be either in a straight or a bent line, depending on if it's going by a mass and deflected, to the target or the observer, however you want to look at it. In other words, starts here just as it leaves the source, goes, it travels, propagates through space or the atmosphere, whatever, and stops just before it reaches the retina of the person here, right? I just call it light in transit. It's transit between two objects, the source and the observer or target, right? So what are some examples of this? Like I said, you know this from when you were little. If you look up at the sun, right, you are seeing the rays that left the sun like 8 minutes ago as we're on Earth. But if you block out the sun and then perpendicular to the sun, you block out the source and you block out the target, right, you don't see the light waves going through there, right? They call it white light, which is a misnomer, but it's basically transparent light, right? All the different frequencies of the colors of the visual spectrum, right? It travels, but you don't see it. You don't ever see the light. It's light in transit. And that's like if you put blinders on, and white light, again, all the colors of the visible light spectrum, or a laser, like a little pointer. I'm not going to get into a lecture about lasers, but on a basic level, a pointer works as a small laser, very low power. You turn it on, you click the on switch, it sends out a beam, but when it leaves the beam, or when it leaves the laser, you know, the lens on the laser, and goes out and then hits whatever the target is. Again, but if you block it, you know, the laser itself, if you block the object, you know, what the target it hits, you don't see the light passing through there, right? That's just light in transit. So it's just going from one source to another. And in and of itself, you know, it's not mind-boggling, but it does have applications and interesting ones. Right, it can't be seen. Light in transit can't be seen, and it has no major objects in it, no light-emitting sources in and of itself. Right, it's just light. What you can do, you know, following this is like in a simple example. If B, you know, is a person on a hill, A is the source, and C is the hill in between. When the source turns on the light, you know, it goes from A by C and into B. And so you'll see it from that source, whatever time it is, and, you know, speed of light and the distance and so forth. But so you can see it. What you can't do with light in transit is to intercept the light, like halfway or whatever you want to do, and say, at this point B, I would like to see what the light looks like at point C in the same time. You can't do that. In other words, you can't look up a beam of light and halfway say, oh ho, that's what the light looks like at point C, right? You can't do that. That's just one of the situations with the light in transit. You can't interrupt or intercept the light beam just by being a person and looking at it. I mean, what you can do is, if you really wanted to see it, you could move yourself from B to C, and then you would see it. You could move A to C, and then you could see it, at least maybe if it's halfway the time. You can do something by putting an object in there, like a translucent object, that would, you know, hit the light here would hit the translucent object and then pass on to you, but you wouldn't see it at that time, at that way, because of the distance still here. You can put an object there, or maybe an object that shines, but that's not that light, it's another light that goes here. So basically another idea is light in transit, not physically possible to intercept or interrupt the light path, right? You can't do that in any meaningful way without getting kind of weird ideas, ceteris paribus, other things being equal. That's what I wanted to point out, and that's the main aspect of it. You know, looking at a light as a person or whatever, you can't go, I'd like to see what it looks like, you know, 3/4 of the way to the sun. You can't see that unless you do some physical object, you know, right in there. So, I mean, that's sort of the basic background. There's nothing major here. Basic ideas, you know, white light, light in transit, you can't interrupt it. It might be bending, it might not be bending. You know, it can't be seen, right? It's moving and it can't be seen. I'll save that for later. So that's kind of what's going on here. All right, let me get to the other one. I don't know if you can see this, but really it's nothing more than what I have shown before. In other words, before I had the source over here, a hill between the source and the target, and the observer or target over here. All I've done here is to sort of replace it, you know, vertically with another system, but it's basically the same exact system that we had before. So we have a source, whatever that is. We have a mass, you know, whatever that is. And we have a target or two observers here below. These two are light in transit, right? It goes from the source, it bends, it goes directly to the observer, right? So it's white light I'll call it. Light, yeah, like a light ray or light beam going through here can be any shape, right? It can be any shape that whatever the source might put out. Again, I mean, you can wait for the source to hit here, but what you can't do is see, I would like to know what the light looks like at that point. Right? And it's coming here and I say, I want to look up that light beam to see what this point is happening right here. Same with this observer, right? That's why the X's are here. At that point, right, like the diameter of the mass for ease, you can't look up the beam and see what light looks like at that point at that time. Or, you know, another time, right? It's not physically possible to do that. So that's what I've been talking about. I just put light bending. It could be Newton or Einstein. It can only be seen by moving. In other words, you could move to this point, which is unlikely. But you can't, or an object could be there, you know, that either is translucent and passes it on, or solid and blocks it. You could put an object that shines, but you can't look up there and say, well, that's what I see. So in other words, as I did before with the three hills, you can move to, you know, X yourself, or you can put something in there, but you yourself can't look up the beam and say, yes, that's what it looks like at that point. Not possible. So what I'm getting, let's see, at this point, the only manner to see the image, is if in reality the image is an actual object. In other words, if these are just light beams coming through here, and there's, like I said before, it's just light, right? It's just white light. If they're coming through here, you're not going to see this. Either that, or is an object there, right? In other words, if this is a system and you're looking at it, I mean, you'll see the light from the source, but the only way that's physically possible to see something from that point is if that point is an actual object. You can't see anything at that point from any other way. Whether it's, you know, translucent, like I said, or an actual physical object, or a physical object produces light, but then it's not from the source, right? So, again, white light bending, object is Brad, so let me see. It's a little bit bumpy on this one, so we can't, I can't really see what that, oh. Yeah, I just said about moving from one place to another. But down here again, you know, the image is an actual object.